Okay, so what I want to cover in this video is something called end behavior. So the questions are going to look something like this. Uh, what value does this function approach as x tends towards infinity? Okay, what we're doing is we're trying to answer the question, what does this function look like? What y values does it approach as x gets bigger and bigger, positive in this case? So the end behavior of a function, it's going to be the y value of the function for large values of x. Okay, so like as you plug in bigger and bigger numbers for x, what's happening to the y values? That's what we're looking at. Whether the y values are decreasing or increasing, where are they headed? That's the question we're trying to answer. So to start out, I just have a graph here, and if I read this statement, as x tends towards infinity, what's happening to f of x? Okay, so notice here, as we go to the right forever, as x gets bigger and bigger and bigger, uh, the y values start falling off. The y values start getting smaller and smaller. So we would say as x tends towards infinity, the y values, f of x, tend towards negative infinity. Okay, they're going downhill. Okay, and then the other half of the end behavior would be as x tends towards negative infinity. That's what this part means. As my x values get bigger and bigger negative, the y values get bigger and bigger. All right, the y values are tending towards positive infinity in that case. Now, you can find the end behavior by graphing it and looking at the graph. But there's going to be some tricks and rules that we'll cover. That's really going to be the main portion that you'll need to catch on to. But this right here is another way that you can kind of determine the end behavior for any function. You can literally just plug in a big number for x. Now, obviously, we couldn't on this one because we didn't have an equation to plug it into. But to find the end behavior, what you can do is just plug in a big number for x, like 100 or negative 100. I'll show you what I mean. We'll do that for this example. Okay. So I'll graph it here in a second so you can see what the graph looks like. But let's answer the question without doing that. Okay. So what is the value of the function as x approaches really big numbers? So if I just take 100 and plug that in for x, of course it's just going to be 3 times 100 plus 2, and you get 302. Okay. Notice that it's positive 302. That's the important bit. If we were to plug in an even bigger number for x, say 1,000, of course we would just get 3,002. And the bigger number for x, the bigger number that we plug in for x, as x gets bigger and bigger towards positive infinity, the value of the function tends towards positive infinity. That would be our answer here. Okay. If we looked at the graph of 3x plus 2, this is what it looks like. And the idea is, as you go to the right forever, as you go further and further right on this graph, let me zoom out, the y values are getting bigger and bigger. They're headed towards positive infinity. Now, if the question was the other way around, if it had said, what happens as x gets closer and closer to negative infinity, we would have been looking to the left side of the graph. And of course, in that case, the y values are going to negative infinity as well. Okay. The next question is, what is the value of f of x, this function, as x tends towards negative infinity this time? Okay. So if we plug in a really, really large negative number, say, we'll just do 100 again. Okay. If we plug in that number for x to the fourth, This is just a way that it can be done. I mean, you could graph these functions to see what they look like, or you can actually plug in some number for x just to see what's going on. So I just plugged in 100, and you see the answer I got was a really, really large positive answer. So in this case, my answer is probably going to be positive infinity. Okay. Oh, you know what? I just realized I plugged in positive 100, didn't I? I should have plugged in negative 100. All right, no worries. It's also going to be a very large positive answer in this case. Okay. If we look at the graph of it, it's a little bit harder to tell on the graph of some of these because, well, just because the values of these functions are huge. But the key thing to look for is the direction that the function is pointing. This function is pointing up and to the right, and it's pointed up and to the left. So whether you go to positive infinity or negative infinity, all right, the value of the function is positive infinity. The y values are tending towards up, up, and away. All right, they're always getting bigger. Okay. Before I go into the rules, I just want to look at one more. These have been polynomial functions. All right, polynomial functions will be the main focus. I'll get into these rational functions in the next video mostly, but I just want to show you that you can answer these questions without having a bunch of rules. All right. What is the value of this function as x approaches positive infinity? Okay. So, I'm wanting to know what happens to this thing as x gets really large. That's what this means. So let me just plug in 100 for x, just some number. You could do 1,000,000 for x if you wanted to. All right. And if we type in this function, we just want to see, what it looks like. What kind of outputs are we going to get as x gets bigger and bigger positive? Okay. I got 0.01009, which is a far cry from infinity, right? It's not even close to infinity. It's not negative infinity either. If I did 200 for x instead. All right, I'm getting smaller and smaller values. Ultimately, the answer to a question like this would be 0. That would be the answer to this particular question. For rational functions, which we'll look at in more detail next time, there's some different situations that come out, okay? But that is the scheme for how you can find the end behavior for a function, okay? You can, you could graph it and then kind of see which way it goes, or you can literally plug in numbers for x, okay? All right. Next video, we'll go over some of the rules for these.